Alright everyone, you have survived Units 1 and 2, and here we are in Unit 3, Lesson 1. We have one objective here. We're going to find square roots, cube roots, and nth roots. Nth just meaning they could be any root to a higher power than 2 or 3. I think generally most people find this to be one of the easier lessons in the course, so this shouldn't be too bad. Let's get to it. First of all, let's start off kind of basic here. Most of us understand this concept that the square root of 64, for instance, when you take a square root, you can get a positive or a negative value. In general, this is equal to positive or negative 8. And think about why that is. That's because if you do 8 times 8, you get 64. But also, if you do negative 8 times negative 8, you get 64. So in each case, if you square 8 or you square negative 8, you get 64, which is why the square root of 64 is both positive and negative 8. However, in general, unless you see that plus or that minus out there, we're going to specify one or the other. Generally, when you just see the square root of 25, that is going to mean the positive or the principal square root, the non-negative square root. And I'm just going to write that out here beside. This is called the principal square root. In general, unless we specify that we want the negative version, unless we say, give me the negative square root, we're going to go with the positive or principal square root. So if I wanted the negative square root, I would put a negative out front like this. Negative square root of 25. Now I know that means negative 5. Okay. Now, for that you could put it in your calculator. And of course, let's also remember the difference between this and this is that what I've just written is not a real number. This is not a real number. You cannot take the square root of a negative. In fact, you'll see we can't take an even root of a negative number. Okay, so it's not a real number because there's no number you can multiply by itself and get a negative. There's not a number you can multiply by itself and get negative 25. That's not possible. Okay, so let's look at something that's maybe a little bit more involved here. Let's do, let me go further down, the square root of 36x to the 6th. Okay, now this has two parts, and a property of square roots that we will talk about later in this unit, but there's no reason to wait until then, is that we can split this up and think about it separately. We can think of the square root of 36 and the square root of x to the 6th. We can think about those things independently. Let's split this apart, take each square root, and then put them back together. Well, we know that the square root of 36 is 6. But what about the square root of x to the 6th? Well, think about it this way. Let me write this out underneath here. You've got x to the 6th could be rewritten as x to the 3rd times x to the 3rd. If you remember your rules of exponents, when we have it written like this, we just add these two exponents. So 3 plus 3 would be 6. That's the same thing. Because what we're saying is, here I have 3 x's, and here I have 3 x's. If I put those two things together, I've got 6 x's. Okay, so now, well, that's the same thing as saying x to the 3rd, my x will cooperate, squared. Because I'm repeating the factor. Anytime I multiply something by itself, I could just as easily say that thing squared. Just like up above when I said 8 times 8 is 64, I could have written that as 8 squared is 64. Okay, well, if I'm taking the square root of this, if I come in and I want to say, well, what's the square root of x cubed squared? Well, what you should notice is that the square root and the square are opposite operations. They cancel each other out. Square root, square. They cancel each other out, so all I'm left with is x cubed. And so that's the case here in my example above. So I had 6 was the square root of 36, times the square root of x to the 6th, which is x to the 3rd. And that's how we do that. We're just thinking, what can I multiply by itself and get x to the 6th? Well, x to the 3rd times x to the 3rd is x to the 6th. So that tells me x to the 3rd is the square root I'm looking for. Let's do another. The square root of 4x squared y to the 10th. Now again, we want to split this up and consider each part separately. Let's think about the square root of 4, and then let's think about the square root of x squared, and then let's think about the square root of y to the 10th. And we can do that all at one time. Well, the square root of 4 is 2. That's the easy part. The square root of x squared, again, you have a square root and a square that cancel each other out. What you should be thinking is x squared is equal to x times x. So that means the square root of x squared is just x. Now what about y to the 10th? What can we split y to the 10th into? We can split it into y to the 5th times y to the 5th, because 5 plus 5 is 10. Right? So that means the square root of y to the 10th is y to the 5th. And there's my answer, 2xy to the 5th. I think that's not too bad. People generally have no problem with square roots. Now we're going to get into some cube roots, which is the same concept, it's just with 3 instead of 2. So I want you to think about this. Let's start with this statement. 2 times 2 times 2. What does that equal? That equals 8. 2 times 2 is 4, times 2 is 8. Well, what does that mean? Therefore, if I want the cube root, and the cube root is just a square root symbol with a 3 up there in the corner. By the way, this symbol is also called a radical. You hear that term radical. That's math talk for this symbol. It's called a radical symbol. So the cube root of 8, well, we just showed what the cube root of 8 is. We're thinking, what number can I multiply by itself 3 times and get 8? Obviously, that would be 2, because 2 times 2 times 2 is 8. So again, another way I could have written this over here is 2 cubed is equal to 8. Well, if 2 cubed is 8, then the cube root of 8 is 2. Those are inverse operations. And I want to show you real quick, this is an easy one, people know about 8 already, but I want to show you where you can find this on your calculator. This is just an emulator of a calculator I've got here. Cube root is easy to find, and any root actually, and we'll do this again in a second. If you want the cube root, you want to go over here to the math button, right here under alpha, and then the 4th option down is cube root. You'll see it's a square root sign with a little 3 in front of it. Hit enter. Now I can take the cube root of whatever I want. Cube root of 8 is 2. So for these that just involve whole numbers, feel free to use your calculator to check it. There's nothing wrong with that. I'm happy for you to do that. Just know how to use the calculator to find these things. Okay, where was I? Oh, let's look at one that looks like a fraction. That looks kind of crazy and difficult, but it's really not. The cube root of 27 over 64. Well, just like with multiplication, where we can split terms apart, let me go back up here a second. Up here with this problem, where I said we could take that 36 times x to the 6th, and we could look at the square root of each part separately. We can do the same thing with division. So I can come and think of this as the cube root 27 over the cube root of 64. I can think about the top and the bottom independently, which is good because we know the cube root of both of these. And if you don't, feel free to check it on your calculator. If you don't have one of these TI-83 or 84 calculators, you might want to invest in one because you're going to need it for college algebra or statistics anyway. So you should get one. But let's think about this. We're saying what number multiplied by itself 3 times is 27? Well, we can rewrite 27 as 3 times 3 times 3. If you just do the prime factorization, that's what you would get. And we could do the same thing with 64, but with 64, it would be 3 fours. 4 times 4 is 16, times 4 is 64. So now that we see, oh, we have 3 factors under here, well, then that must be the cube root. The cube root of 27 is 3. The cube root of 64 is 4. So my answer is 3/4. And if you wanted to check that, work it the other way. What we're saying is, if this statement is true, if we have the cube root of 27 over 64 is 3/4, then the opposite ought to be true. I ought to be able to take 3/4 to the third power and get 27 over 64. And you can see that I do, because this is 3 to the third over 4 to the third. 3 times 3 times 3, 27. 4 times 4 times 4, 64. Easy to check and verify that, yes, in fact, that is the correct result. But again, that's one you could get in your calculator just by entering the cube root and put 27 divided by 64 in parentheses, and it will tell you. Of course, it will give you the decimal version. Let me do that real quick, because I want to make sure everybody's familiar with how to do this. I go math, down to cube root, or I could just hit number 4. Now it already opens a parenthesis for me, so I do 27 divided by 64, close, enter, and it's going to give me the decimal version. But if you aren't familiar with this already, of course 0.75, you should know that's 3/4. But if you didn't, go to the math menu, and the first option is fraction, so you just hit enter, and enter again, and it will automatically give you that decimal in reduced form. It will reduce it to the lowest possible fraction, as reduced as it can. So that's good to know also for your future assistants. But now here's one that your calculator won't do you much good on, because you know I'm not going to just give you a load of problems that you can do completely on your calculator. That won't. You've got to be able to use your brain a little bit more than just the calculator. We have the cube root of x to the 15th, y to the 24th. Well, again, we can split this up. Let's think of this as the cube root of x to the 15th times the cube root of y to the 24th. And now let's think, what can I multiply by itself 3 times and get x to the 15th? You could think about it this way. You could do that. You could say x to the 5th to the third power. If you remember your properties of exponents, this means we would multiply the exponents. 5 times 3 is 15. Or you could actually list it out. What is this actually saying? It's saying I have 3 of whatever's in parentheses. Well, what's in parentheses is x to the 5th. So I have 3 of those. Either way, what this should show you is that the cube root of x to the 15th is x to the 5th. And we can do the same procedure for y to the 24th. Essentially, all you're doing is you're taking that exponent and dividing it by 3. And if you were doing a square root, you would take the exponent and divide it by 2. That's the shortcut for what we're doing here. So y to the 24th could be listed as y to the 8th times y to the 8th times y to the 8th, even though that middle one doesn't look like an 8. I promise it is. So then the cube root of y to the 24th is y to the 8th, and there is my answer. Okay. Bueno. How about this? The 4th root, oh how dare I, of negative 16. Now I mentioned this earlier, but let's think what number, if you multiply it, and there is my phone ringing. Isn't that a lovely sound to hear? Okay, I have to regroup and figure out where I was. I apologize for that. You got to hear the shrill sound of my office phone going off. Okay, so I was saying the 4th root of negative 16. Well, the 4th root works just like the 3rd root or the 2nd root does. Of course, we don't say the 2nd root, we say the square root. The 3rd root, we say the cube root. But beyond that, we don't have a cute little saying, so we just say the 4th root or the 9th root or whatever the number may be. So what number multiplied by itself 4 times, or another way to think of it is, we're looking for some number, I'll call it x for now, some number that I can raise to the 4th power. That's what I'm looking for. I really shouldn't have an equal sign there. That's not equal. I'm looking for what number raised to the 4th power is equal to negative 16. Yeah, let me move this because I don't want that there. This is equivalent to saying what number to the 4th power is negative 16. I'm looking for something I can multiply by itself 4 times and get negative 16. Well, you might think negative 2, but what happens if you do negative 2 4 times? You can see that that would be positive 16. Negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. 4 times 4, positive 16. So the point here is this is not possible. This is not a real number. There is no real number that exists that you can take to the 4th power and get a negative number. And this we can generalize to all even roots. We don't have to just talk about 4th roots or square roots. So let me make this statement as clearly as I can, and I'll write it here in red to make it obvious. You cannot take an even root of a negative number. Now, this does not apply to odd roots. We can take odd roots of a negative number, right? Because, for instance, let's say the cube root of negative 27. Well, I can take that because we can rewrite negative 27 as negative 3 times negative 3 times negative 3. Since I've got an odd number of 3's there, that answer does turn out to be negative, so the cube root would just be negative 3. So it's okay for an odd root, but any even root, you can't have a negative number underneath the radical. So that's the important thing to understand. But of course, if I wanted the 4th root of, say, positive 16, then that would just be 2. Because 2 to the 4th power is 16. And I do want to again show you how to do this on your calculator. I showed you cube roots earlier. If I wanted the 4th root, let me do a bigger one here. Let me do the 4th root of 81. What you need to do if your calculator is like mine, now if you have a more advanced, an 84 with a newer operating system, you may be able to enter this number in after you go to the math menu. But if yours is like mine, you want to hit the 4 first. That's going to be my 4th root. Then go to the math menu. And if you'll notice, the option below cube root, the 5th option, has an X in the position of the root. That's the one I want. Hit enter. Now what that's doing is that's putting a 4 in for that X. It's saying I'm going to take the 4th root of whatever you put in after this. And I'm going to put in 81. And it says 3. Because 3 times 3 times 3 times 3 is 81. But of course, if you tried to do that with a negative number, let me repeat this entry. If I tried to put negative 81 in here, it's going to tell me error, non-real answer. It says, hey, I can't do that. It's telling you that's not a real number. I don't deal with non-real numbers. Okay, so just a little calculator advice there. All right. So you would be able to do this with any root you wanted. Let's say you wanted the 7th root of 128. Well, you probably don't know that off the top of your head. So you go to your calculator and you say 7, math, 5th option for the xth root. We're going to make it a 7th root, 128. Enter. Oh, it's 2, because 2 to the 7th is 128. So this would be 2. So that's how you can use your calculator to do these higher level ones. All right, a couple more points here, and then we'll be done. Just like I've written this before. If I have the square root of 3 squared, we know that the square root and the square just cancel each other out, and that's equal to 3. Well, the same thing is true with any other expression and any other root. So for instance, the fifth root of x plus 7 to the fifth power, well, the fifth root and the exponent, that's a 5, cancel each other out. So this is just equal to x plus 7, whatever's in parentheses there. So that's what I want to make clear, that a root and an exponent of the same number cancel each other out. A square root and a square cancel each other. A cube root and a cube. A sixth root and something to the sixth. They cancel each other out. And then the only other thing you might do on this assignment, I think you have one of these at the end. Let's say I gave you this in function form. Let's say I said f of x is equal to the, let's go, well, I don't think I'll have cube root. I might have cube root. That's fine. I'll just leave it a cube root. The cube root of x plus 5. Now I say find f of 3. Well, that just means plug in 3 for x. So that would be the cube root of 3 plus 5, which is equal to the cube root of 8. So hopefully you know the cube root of 8 is 2. So then the answer would be 2. F of 3 is 2. Or another way to think about that is, when x is 3, y is 2. That's basically what we're saying. But say you were given one that didn't work out evenly like that. Let's say I asked for f of 5. Well, f of 5 would be the cube root of 5 plus 5, because I'm replacing x with 5. And so that is the cube root of 10. Now, since that doesn't work out evenly, I want an exact answer. The cube root of 10 is a number that goes on and on and on forever. It's not rational. It's an irrational number. So I would just leave my answer in this format and enter that into my math lab. Unless they ask specifically for a decimal answer rounded to the nearest however many decimal places. But I don't think they will. Okay, that concludes Lesson 1 from Unit 3. You should have no problems with the assignment.